All right, we left off. This is going to be part 2, or part B, of section 7.4. And what we came up with was 4200s, which is everything that's not in a Z and not in Y. RB is the probability of Z prime, not Z, union with I. Okay, that's a different animal. Okay, so in our van, this is our Z, this is our Y, and it's our 17, and 20.29, 2900s, and 1200s here. And 42 floaty. Okay, so they're saying not Z, which is everything that is not Z in the van. There we go, all of that. And then they want union with plus, not U. And I forgot my hyphen, sorry. Now I'm going to do not U. All right. So that's going to be all of, oops, sorry. Got it all here. And they're saying, oh, well, it's just me. Okay. Well, what it means is all of the orange and the pink and the yellow. So the only thing we have that is not included is the 17. So we've got the 0.29 plus the 0.12 plus the 0.42. And we'll do it on our calculator. Because union needs to add everything together, right? So I get 83. Well, it's the same as saying 1 minus the 1700s. I get the same thing? Yes. So either way that you want to work this is good for that particular problem. All right. So let's look again at what they want on the C. C is the probability of Z prime union Y. Okay, we're adding not Z and Y. All right, so here we go. Let's go ahead and draw our Venn diagram. Right. So let's see what we get. So we're going to say first, not Z. That's our yellow. And we're going to add to it Y. So this is all not Z. And we're going to add to it yellow. So we have an overlapping of 0.12, but we had an addition of 0.17 with the 0.42. Right. So this is going to be 0.42 plus 0.17 plus 0.12. And I get 71 hundredths. Right. You get the gist. And I'm not going to do the last one. That's just overkill. So you'll get that from watching the rest. Odds is done for betting. I think betting is two T's. Might be one. Betting. Right. So that's when you go to horse races or you have spreads or all kinds of things in gambling. And that is, if it's in favor of it, then it's the P of E over the P of not E. Okay, so what it is the cardinality of the event and the cardinality of not the event, because the probabilities cancel each other out. Okay, so we can have it in favor of or against. Against means not winning, all right, or not, or whatever the condition may be for the study. All right, so let's do an example here. A single fair six-sided die is tossed. Find the odds in favor of rolling a 4. Odds, sorry. So in this rolling of the 4, we know it's only, okay, so the probability of the event over the probability of 1 minus the probability of the event. All right. So let's look at all of it before we just make sense of it. All right. Because that's not the event. So we know, get rolling a 4, there's only one chance in 6. And that's that probability. And not rolling is 5 out of 6. The total of the two probabilities is 1. It's either is or is not. So you add them up and you get that number. Okay, but for math, we do a keep, change, because that's division, flip. All right, when we do that, the sixes cancel. And I have what our solution is. 1 out of 5 opportunity of in favor of the odds. 5. Not bad. A marble is drawn from a box containing 2 yellow, 3 white, and 19. Looks like 24. Find the odds in favor of drawing the following. a yellow marble. A yellow marble is 2 over, our total is 24 minus 2. So that's going to give it 2 over 22, 1 over 11. And that's making sure that we are able to reduce everything in a good form. And it can be, so it's 1 out of 5. And it can be, oh, where am I at? Oh, I'm at the yellow. Sorry about that. I forgot when I went to the 1 over 5, it can be 1, 2, 5. Numerator to denominator. Once you have that odds, depends what the calculator wants, the computer. All right, so in this case, I have a 1 in 11. So that is 1 to 11 chance, the odds in favor of drawing a white marble. Right, let's do the B. A blue marble. A blue marble, there are 19 over 24 minus 19. In this case, if I subtract here, I get a 5. So this is 925 or 925, and the other one was as well. 1, 2, 11. All right, let's do our C. A white marble. Well, in white, we have 3. So our probability is 3 out of, and our total is 24. Okay, to get the odds. And the rest are 21. All right. The numerators will add up to the denominator at all times for odds. So this means I'm going to do a keep, change, flip. That gives me, what's that give me? 21 over 24. Sorry about that. Let's cancel. Sorry. 3 out of 21. That reduces to 1 over 7. 127 or 127. Okay. All right. I have one more of this one, and it is not drawing a white. Not drawing a white. Well, not drawing a white means that we would do one minus, and they're odds of a white. Right, so this is 1 minus, and remember the white was 1 to 7. That would give me 7 over 7 minus 1 over 7 equals 6 out of 7. 1 being 7 over 7. So, common denominator. All right. So, here we're going into converting odds into probability. Well, that means we need the total in the bottom. And if you notice, it is the numerator plus whatever the denominator was to begin with for odds, because the top is always the same. And let's talk about the properties of probability. Probability has to, the highest it can get is 1. 1. It can be less than or equal to 1. And that's it. It cannot be greater than 1. It can be 0, but it can be a negative number. So that's what they wrote here. The sum of the probabilities has to equal close to 1. Not always that happens. So we have a few problems here. Not anything major, but something that we can see how each of the individual probabilities. So an experiment is conducted for which the sample space S equals S1, S2, S3, S4, S5 in the following probability assignment possible for the experiment. In other words, does the sum of individual probabilities equal 1? All right, so that means we have to add them. All right, so we're going to take our calculator. Oh, that's it. I forgot to wear my glove. I got to put on my glove. I'm wondering why all these windows open. So we're going to use our calculator, and we're going to enter the decimal 1/6 plus decimal 2/3 decimal 22 plus oh, mercy sakes, let me clear that. Decimal 1/6 plus decimal 2/3 plus decimal 22 plus 7 plus decimal 32. And I get 103. This is very small, this part here. And this is, they're asking if the sample space probability assignment for the experiment. Yes. The sum is very close. Therefore, it's a good data set. Usually you see 3 decimals to help get closer to that number. In this case, we want to add them and see if they equal 1. 1 divided by 4 plus 1 divided by 5 plus 1 divided by 7 plus 1 divided by 10 plus 1 divided by 13. And as I added all of these partials into, oh look, I made a mistake there on the 10, sorry. Let's see what I can do here to remove it. That was 1 divided by, oh, I see what I did. 1 divided by 10. Okay, got that. Plus 1 divided by 13. I'll enter. Oh. this one is 0.69, whatever. This is not, so it's not close to 1. All right. I'm going to stop right there.